Hey guys, what's going on? I'm here with a CodaLab tutorial series. This one's on creating a Spiderman controller in Unity. So we're going to start off with the goals for the series. There's three goals. Number one, so we have to be able to swing around in 3D space. So in 2D games you can only go left to right. In this case, we're going to go every single direction that you can known to man except the fourth dimension, because that would be ridiculous. So left, right, forward, back, up, down, we can do it. We'll be swinging in all of those directions, as you'll see. The second is to be able to swing, and when we hit things, actually intersect and slide along them, just like we would if we were, walking around on the ground with a normal Unity controller, And the third point is we should be able to do this whenever we want, as in transition in and out of the swing. So we could be jumping and then just, grapple onto something and start swinging along close to the ground. Lots of cool cinematic things like you see Spider-Man do. So we'll be able to do that as well. So let's get started. Okay, here we go. So what we're going to do is first we will open a new Unity project. We'll just go new and we'll call it Spider-Man controller. Okay, and then we'll just go create project. Right, now the first thing that we should understand is that in this first tutorial we'll just do all the setup work so that the next phases of the project can just sort of be bolted on sequentially, and we'll have a lot more interesting things happen on the screen then. But for this first one, what we'll do is we'll just get all the components ready. So we need to create a few classes. The first one is going to be an arm class, one's going to be a bob class, and one's going to be a tether class. That sounds really, really random, but it'll make sense very shortly because I will open up this on the screen for you. So this is our pendulum, and this is how we're going to represent a swinging motion on the player when we are swinging. So the pendulum will, might start up here, and then we'll be swinging because we'll be constrained by this tether point up here. So this is just showing us how we represent a pendulum in 3D space. So we need a tether, we need an arm, and we need a bob. And the bob in this case is going to be us. It'll be our player. They'll be the bob. We can call them bob if we want. So we need to create classes for those things. So we'll create a new C# script, and first we'll create the bob. Okay, and then we'll create ones for the arm and the tether as well. Okay, so now we've got those three, we can open them up and we will remove the mono behavior tags from them because they will just be normal C# classes and we won't be using them as mono behaviors. That comes later on. So the arm, if we look at this picture, the arm is just really for us a length. It's the distance between the tether and the bob. That is all the arm is for us. So when we create a class, it'll be very simple. So we'll go back to Unity and we'll open up our arm and we'll be able to remove these things because we don't need them anymore, and we can remove mono behavior as well because we don't need that. So all our arm consists of is a public float length. And the other important thing that we have to do here is we have to add a system serializable tag so that we can represent this in our other scripts later on. So we'll just put that in now. There we go. All right, and now we'll move on to the arm. I mean, not the arm. We'll move on to the tether. Okay, same deal here. So we just remove this, bit useless. Remove that. We'll add the tag. Now our tether is this point in space here. So a tether, we know straight away, has a location in 3D space that we need to capture, and it has a position associated with that. So in terms of Unity, we can use a vector 3 and a transform for those things. So we'll go ahead and do that now. Cool, all right, so we've represented our tether and our arm, these two separate pieces of our pendulum, and now we need to do the bob. So what we'll be using to show our players sort of position at the end of the string. So we'll just go into let this compile, then go into our bob script. Remove this stuff again, and we'll have put a serializable tag on top, just like the last two. And then we'll create the properties. So serializable tag first. So our bob has a speed because it'll be moving around. The tether will stay in the same place, hence the name tether. You know, it's when something's tethered to something else, usually the place the tether is it's what's constraining the movement of the thing that's swinging around it. So in this case, the bob is the thing that's swinging. So we need to have a velocity captured, which we can use vector 3 for. And also we're going to modify that position by having some gravity. So first things first, we'll put velocity and gravity in there. I've just placed 20F for the gravity value just to make it a little bit snappier for our simulations. And we also need to use vector 3 to represent the direction of gravity, because if we wanted, we could have this go anyway. Gravity could be sideways for us, and we could do some inception things if we wanted to, or it could be completely reversed and the gravity could be upwards. And we can control that using this vector. So this is a new vector 3, and we're going to say it's 0, 1, 0. So 0 on the x, 1 on the y axis, and 0 on the z axis. And then this is 1 instead of -1 because we're going to subtract it from our velocity. As you'll see next up, we're going to create a new function called apply gravity. And all this is going to do is modify the velocity using our gravity and our gravity direction. We also need to make this public. There we go. So velocity minus equals the gravity direction. So in this case, 1, just an arrow pointing straight upward basically. And the length of that vector will be our gravity, so 20. So the length of the arrow, the direction this is going, is going to be 20 units. and we're going to multiply that by our time.delta time, so the change in time. So our velocity will add this gravity direction to it each time we call this function. Okay, so we've got all three of those parts of a pendulum. So now what we can do is we can have another script, and we'll call this one pendulum. And what we can do now that we have these other ones is they're basically little parts of this big idea, this concept that is a pendulum. So we can add them to this script. And this is going to be the same as the other ones in that we're not going to use it directly as a behavior. So we can remove these things and the mono behavior. We're just going to use this to represent our pendulum physics model, and we can use that later on in an actual mono behavior script. And the reason we're doing it this way is because it's much more flexible, and if you put it in classes like this, it's much more modifiable and modular to change later on. So if we wanted to change some part of the bob, we don't have to extract that from a whole bunch of other meaningless stuff like the arm value or the tether position. It'll be a nice compact separate modules that we can just look at and go, oh, okay, modify this. So since we've already done all the other parts, we can just add them in here. Cool, so let's compile that and make sure it works inside Unity. So I'll just save this one, go back to Unity, let it compile, no errors. So now we've got all the parts of our pendulum ready for use. So now we need to put a bob and a tether object in our scene to represent those two parts. The arm will create later on a line renderer so you can see the arm itself, but right now we don't need it, we just need to test. So we'll leave that for later. So we go game object, 3D object, sphere, and we'll call this one Bob. And then we can duplicate that and we'll create a tether. There we go. So now that we have those in the scene, we'll set it up so that we can see them and they're in different places. So the tether can be at the center point of our world. The bob can be 10 to the left on the X, or to the right, I suppose, on the X axis. So we'll just go 10 there. And then we'll move the camera so that we can see both of those things. Oh, camera preview, yep, you can see that. So if we go to the game view, you can see both parts are there and we can see both of them. So that's good. Right. Now, the thing that will happen is when we're clicking on something, like if we click on some part of the object, we need to move relative to that tether. So at the moment, we've just got a tether point in the middle. That's just going to be our tether object. So that's cool. But they're completely separate in the inspector here. You can see that they have no relation to each other, and we want them to have a closer relation. So how we can do that is we can parent the bob to the tether, and we can do that with code so that later on we can add and remove them just using mouse left and right click, so that it's not hard coded in to be always a child of one particular tether in the scene. For this example, what we can do is we'll write the code, but we'll make it almost a hard copy by doing it on an initialize function inside the pendulum. So we'll go back to our pendulum script. and then we'll go public void initialize. And once we're in here, we can do two things. We can do the parent-child relationship we just talked about, and we can also set the length of the arm, because we already have the transform of the bob there, and we know where the tether is because it has a position value. We'll be able to work out the distance between the two. And the distance between the two is the arm itself, that's the length. So we can do that in this initialize function as well. So we'll go bob_tr.transform.parent is equal to the tether.tether transform. Oh, whoops, not the position, just the transform itself. And now for the arm length, we do vector3.distance, and it's between the bob's local position, because now it's a child of the tether, and the tether position. There we go. Now we can save that, and we'll go back to Unity. So now we've got all of these scripts, but we can't actually drag them onto our bob and use them, because what we did was we used system.serializable on all of them, because they're just they're abstract, almost abstract kind of concepts. So what we'll do is we'll create a monobehavior class that will use the pendulum. And we can call that, let's say, we'll call that swing. Okay, now we've got our swing script. We can put that on the bob, because that is actually a monobehavior, which means we can attach it to things. There we go. And then we'll open up swing. Here we are. And what we want to do is first we'll be able to use our pendulum finally. So we'll create a public pendulum. Then we can initialize it using its initialize function in the start method. And then when we're updating, we can update the position of the bob using the pendulum move bob function, which we'll write in a moment. We need to serialize this field so we can use it properly in the inspector. Then we'll initialize the pendulum. So that will set the arm length as well as the child-parent relationship to the tether, just like we programmed earlier. And then we want to update it with this moveBob function. And we'll be using the local position because it'll now be a child of the tether. So the move bob method will take in a position and a time, and it will use that to work out what the next position in the update will be. So we can save this and we can move back to our pendulum script and add the move bob method. Oops, actually that should return a vector 3. And we'll take in our vector 3 position and our float time. So currently not returning a value. What we'll do is we'll modify pos and then we'll return that. So the first thing we want to do when we're moving our bob, which is our player, is we'll be subject to gravity. So gravity will be the driving force of how we're going to move while we're swinging, because gravity is really what's the overriding force. The only other thing that's acting on the player at that point would be the tether, like the rope that is attached to the tether rather, because that's what's going to constrain the position. Otherwise it would just fall normally, it'd fall to the ground. But since we're holding that rope, that's going to keep us in this swinging arc path. So to get all that to happen, the first thing we need to do is apply gravity. And luckily we've already written that in our bob class. So we can just call our bob.applyGravity function, and that will move the bob downwards using gravity. So now we can just, since we're assuming the bob is our player at this point, we can say that the position that we're returning to our bob game object using this function is going to be the position plus the bob velocity that we've just modified using this apply gravity function. And now we can just return it. Save that. And now in our swing, this is all green lights, no issues here, no errors. So we let that go back to Unity and compile. Now we have this structure that is a pendulum here. And we've got our tether, we've got our arm, we've got our bob. We've got gravity set to 20 with the position, with the gravity direction up, because we're subtracting it. So now all that's left to do is to put these objects into their relative little slots here. And then we should have the ball moving with gravity in a downwards direction. So first, the bob transform is our bob itself. The tether position is 0, 0, 0. And we have our tether object here. The arm length is going to be set in our initialize function, so that can be 0 at the moment. And our bob velocity we've just got here public so that we can see it. We won't have to modify it directly in the editor, but we'll be able to see it change. And as I said earlier, these have already been set for us in the script. So the only thing left to do is to check to see if it's all worked. So we'll save this and we'll call this test scene. There we go. And now if we run it, we can see that our ball is moving with gravity. And if we check, we've got our tether over here with the bob as a child object, and we can see that our velocity is being modified here in the y direction. So that's it for the first tutorial. In the next one, we'll actually constrain the position of the pendulum to the length of the arm, and we'll start seeing some of this curving motion here, indicating an arc or a path of swinging. So thanks for watching, guys. Hope you enjoyed it, and I'll see you in the next one.